Okay, today we'll talk about dilations, and it's a little different from what you've dealt with before, because before you guys were doing transformations with objects and the lengths were not changing on the objects. This time in a dilation, it's going to change length, and so therefore it's called a non-rigid transformation. So if you see right there, non-rigid. The images, though, are still similar to one another, and you can still use proportions in order to find missing lengths. There's two types of dilations. The first are called reductions, and the second are called enlargements. So let's look at an example. Let's look at reductions first. So you're going to start with a point C. And what you're going to do is you're going to track it to a pre-image. So my pre-image is right here. So I have PQR, triangle PQR, and we're going to create a reduction, or the people created a reduction. And the way they did that is they looked at it, they drew a line from C to P and C to R, and what they did is they moved the object down the line, and in doing so it was making it smaller, so it's a reduction. And I'll explain this part in a second. So the way you can find out what kind of reduction it is, by what scale factor, is by using a proportion. And the proportion you're going to use is you're going to use your prime over your pre-image. So in this case, we have CP prime, so CP prime is 3. So they put 3 on top, we started with our prime, and then they did CP on the bottom, which is 6, and then they reduced it. So this is our scale factor for that drawing. And you're going to notice that they're going to relate the scale factor to K. So whenever they're talking about K, you know it means the scale factor. So if you look here, it says K for a reduction must be greater than 0 and also less than 1. So we look and we go 1/2. That's less than 1. So we know this was a reduction. The image got smaller by 1/2. Now let's look at an enlargement. So they started with their point C, and then there was a pre-image, PQR, right here. So they drew a line from C to P and C to Q. And then what happened is they enlarged it, but they extended their line so that P prime, R prime, and Q prime would be on that line. And this one was an enlargement, and the way they found that out was they have CP, so you start with your prime, CP prime, start with that, it's on top, is 5, and then you have CP on the bottom, which is 2. And looking at this, 5/2 is our scale factor, and so let's check it out. Is 5/2 greater than 1? Yes, it's an enlargement. So if the image is getting smaller, the scale factor is less than 1, you know that it's a reduction. If the image is getting larger and the scale factor is greater than 1, you know that it's an enlargement. So now let's look down at how to draw a dilation. So it says use the following steps to construct a dilation with a scale factor of 2. So let's check, is that a reduction or an enlargement? Well, it's greater than 1, so it must be an enlargement. So there's my enlargement. And so it says using a straight edge. So what you do is first you draw your triangle. So triangle PQR, they drew a triangle PQR. And choose the center of the dilation C. So that means you're coming from Q and you're drawing a line straight perpendicular and you choose where C goes. Then you draw your other lines going right into C as well. So you've constructed your pre-image and you have your point. So then what you're going to do is you want to double all of your distances. So it says you want CP so that CP prime equals 2 times CP. So locate Q prime. So you have Q here. And so if Q is, let's say, over 2 up 1, you double your points. So it's going to be over 4 up 2. So it doubles it. So we go over 4 up 2 and we get our Q prime. So the reason I doubled it is the scale factor is 2. And then you do that for all your other points, and you get your new dilation, which is an enlargement. If you were doing a reduction, you're going to be going the opposite way. So instead of going this way to write your image, you'll be going this way to write your image. So hopefully that gives you a little insight into dilations. We're going to be constructing some tomorrow. All right, have a good night.